Recursive formulas and explicit formulas are two ways of expressing arithmetic and geometric sequences of numbers. In this video, we are going to discuss what each of them are and how to write sequences of numbers using each of these two techniques. Let's consider the sequence of numbers 3, 8, 13, 18, 23, and so on. Can you detect a pattern for this sequence? To get from 3 to 8, we add 5. We also add 5 to get from 8 to 13. This pattern continues with the following terms as well. For this reason, we can express the terms in this way. A sub n is equal to a sub n minus 1 plus 5. This is a way of saying that the nth term of the sequence is equal to the previous n minus 1 term plus 5. The lowercase a's denote that we are talking about terms in a sequence of numbers. The lowercase n's represent the number of the term we are looking at. For example, if we wanted the 7th term of the sequence, we would be looking for a sub 7, and we would need to know the previous term, a sub n minus 1, or a sub 7 minus 1, which is a sub 6. This formula for the sequence is called a recursive formula because it is written in terms of the previous term of the sequence. If we know that the 5th term of the sequence is 23, we can find the 6th term by using the recursive formula. A sub 6 is equal to a sub 5 plus 5, which is equal to 28. When we write recursive formulas, it is important to include a couple extra details. We need to specify which values of n the formula works for, and we need to include the value for the first term in the sequence. In this case, the sequence started with 3, so we would say that the first term is a sub 1 equals 3. After the first term, the recursive nature of the formula kicks in, so we would say that the formula applies for n is greater than or equal to 2. One of the problems that arises when working with recursive formulas is when we need to find the value of a very large term. For example, if we were asked to find the 100th term in the sequence, we would have to know the 99th term in order to use the recursive formula. Working our way up to the 99th term would be very time-consuming. Because of this problem, explicit formulas tend to be used more often. When working with explicit formulas, we express this sequence in terms of n rather than in terms of the previous term. That is, we can write another type of formula which will give us the value of any given term based on what position it is in. Because we already said that each term is 5 more than the previous, we can start by writing a sub n equals 5 times n. Every time n increases by 1, the term of the sequence increases by 5. But we also know that the first term is 3, which is not 5, but 2 less than 5. That is that a sub 1 is equal to 3. To make this work, we can just subtract 2 from 5n, so a sub n is equal to 5n minus 2. Let's check this formula to be sure that it works for the sequence. The first term, a sub 1, is 5 times 1 minus 2, or 3. That's correct. The second term, a sub 2, is 5 times 2 minus 2, or 8. Also correct. The third term, a sub 3, is 5 times 3 minus 2, which is equal to 13. It looks like we've got this formula written correctly. This type of formula for a sequence where each term is written in terms of n is called an explicit formula. Like with recursive formulas, though, we need to include the values of n for which the formula applies. In this case, our formula works for values of n greater than or equal to 1. While recursive and explicit formulas are both useful in math, it is more common to use explicit formulas because you can find any term you want without having to first find all the terms before it. Let's now discuss how to convert an explicit formula to a recursive one and vice versa. How can we change the explicit formula, a sub n equals 10n plus 1, where n is greater than or equal to 1, into a recursive formula? Recall that one of the things a recursive formula needs defined is the first term, a sub 1. Let's start there. We can find the first term in this sequence by using n equals 1, since that is the smallest allowable value of n. This gives us a sub 1 is equal to 10 times 1 plus 1, which equals 11. Next, we need to figure out how one term relates to the next, so we can write a sub n in terms of a sub n minus 1. In the last example, we said that the sequence increasing by 5 with each term corresponded to the explicit formula containing 5 times n. In this explicit formula, we see 10 times n, which implies that for each time n increased by 1, the term increases by 10. In other words, each term should be 10 greater than the previous. This gives us a sub n is equal to a sub n minus 1 plus 10. Now, which values of n does this formula work for? We said that the first term is a sub 1 equals 11, where n equals 1. So the recursive nature of the formula will kick in at the next term and work for n is greater than or equal to 2. Let's check that the first few terms are equivalent to the explicit formula we started with. For n equals 1, we know that 10 times 1 plus 1 equals 11. And we said that a sub 1 equals 11 for the recursive formula. For n equals 2, 10 times 2 plus 1 is 21, and 11 plus 10 is also 21. Similarly, for n equals 3, 10 times 3 plus 1 is 31, and 21 plus 10 also equals 31. This recursive formula works perfectly. Let's now try to form an explicit formula from a recursive one. Consider the formula a sub n equals 2 times a sub n minus 1, where a sub 1 equals 2 and n is greater than or equal to 2. To convert this to an explicit formula, let's try and understand the pattern. Let's use the given formula to find the first 4 terms. The first term in the sequence is 2, then a sub 2 equals 2 times 2, which equals 4. Next, a sub 3 is equal to 2 times 4, which equals 8, and a sub 4 is equal to 2 times 8, which equals 16. Another way of looking at this, though, is that a sub 3 is equal to 2 times 2 times 2, or 2 cubed. And a sub 4 is equal to 2 times 2 times 2 times 2, which is equal to 2 to the 4th. Because each term is twice the previous one, the nth term should be equal to 2 to the n. To add the finishing touch to this explicit formula, we need to define which values of n it works for. We know that the first term in the sequence is a sub 1 equals 2, and because 2 to the 1 equals 2, n equals 1 is valid as the first value of n. Therefore, we say that a sub n equals 2 to the n for n is greater than or equal to 1. When it comes to sequences of numbers, explicit formulas are usually regarded as more convenient to use. We can typically express sequences as either recursive or explicit formulas. Recursive formulas present a sub n in terms of the previous term, a sub n minus 1, while explicit formulas write a sub n in terms of n. Both types of formulas require defining which values of n they apply to, but recursive formulas also require you to define what the first term is. To rewrite an explicit formula as a recursive one and vice versa, identify the first term, determine the relationship between each term in either n or a sub n minus 1, and define which values of n the formula allows. Finally, it is always a good idea to check your work and be sure that the two formulas are equivalent by testing the values in the given sequence. I hope that this video was helpful. Thanks for watching and happy study!